Hello, T-Rex math students. Today we will be going into problem 3.1 from our Moving Straight Ahead unit, and at this point you have just taken the partner quiz. So at this point we will be beginning investigation 3, solving equations. We completed investigation 1, had a checkup. Investigation 2 had a partner quiz, and now we're ready for investigation 3, where we'll solve equations using tables and graphs first, and then move into solving equations using equality, writing equations, solving linear equations, and finding the point of intersection. So as we begin our next investigation, investigation 3, we're referring back to Alana and the distance she traveled during the walkathon. Remember that Alana earned $5 from her sponsor and then 50 cents for every kilometer that she walked. We're going to be looking at this equation a little bit further as to how we can solve for the amount she needs to earn or how we can solve for the distance she needs to walk. For example, if we look at the equation A equals 5 plus 50 cents per kilometer, we can see the line shown in the graph that is formed by graphing this equation, and we know we can make a rate table. But suppose we want to use the equation to figure out if 3, 6.5 is a solution to the equation. What we can do is we can take 3, which represents the independent variable or the distance in kilometers, and substitute it for D. So we get something like A equals 5 plus half of our distance, 3, or our independent variable, which is 3. Half of 3 is 1.5 plus 5, which does actually equal 6.5. So 3, 6.5 is a solution to the equation, which means it's a point on our line. So in investigation 3, we're going to be looking very specifically at how different ordered pairs from rate tables and graphs of lines can be solutions of an equation. So if we look at Alana's equation for the $5 plus 50 cents for every kilometer, we can pick any of these ordered pairs. We just did 3, 6.5, so let's try 30, 20. So 30 represents D because it is in our D column. So if I take my equation and where I see D, instead, I substitute 30 there, I could solve for A, or the amount Alana will earn, by saying, okay, half of 30 is 15 plus 5. So 15 plus 5 gives us an A value of 20, which is shown here in the table. Let's try another one like that. Our equation was amount equals 5 plus 50 cents for every kilometer, or D. So let's suppose we go back and we choose 4, 7. So 4 again represents our input, our independent variable D. So A equals 5 plus, instead of putting that D in there, notice I'm going to put 4. Half of 4, or 0.5 times 4, is 2. And then if I solve for A, I get a value of 7, which is right here. That's our dependent variable. So 4, 7 is also a solution to Alana's equation. If she walks 4 kilometers, she would earn $7. If she walked 30 kilometers, she would earn 20. But instead of graphing a line, I can find a solution using an equation. Today you're going to begin your work on problem 3.1, and you're going to be looking at this equation specifically and answering some questions based on what I just showed you. For example, if I told you Alana wants to earn $10, that would mean A is $10. So if that's true, we want to figure out if Alana wants to earn $10 and she starts with $5 and earns a 50 cents every kilometer she walks, how many kilometers, or D, would she have to walk if A is 10? Those are the things you're going to be looking at today. So make sure you have a book and turn to page 56 and title your Notability file Problem 3.1 for MSA, or you can use your notebook from the crate and begin to work on Part A using the equation as we talked about before.